Hello students, welcome to my channel. So today in this video we will discuss our class 11th physics subject, which is second chapter we are discussing, and also we had made a previous video on this chapter, and upcoming topics will be covered in this video, and our chapter is motion in a straight line. Okay, so let us start our this video, and I will revise our previous topic, that what we had studied in our previous lectures. Okay, so you had remembered about that we had discussed in our previous video regarding of what is speed and velocity, that we had discussed what is the speed and what is the velocity, as well as we had discussed about some terms related to terms related to speed, some terms related to speed, and what that terms were we had discussed in our previous videos. And if I will mention here some terms, that is the uniform speed you had mentioned about in the previous video. Uniform speed we had known, okay, as well as non-uniform speed. What is non-uniform speed? Okay, and then we had discussed about average speed. Average speed we can here write average speed, and also we had discussed about instantaneous speed. Okay, the last topic which we were discussing was instantaneous speed. And here it is very important to understand instantaneous speed, because the questions are directly asked in our examination from the instantaneous speed. I had discussed that what is instantaneous speed. The speed of a body at a particular instant is defined as instantaneous speed, and the expression for the instantaneous speed was given as what we had described it as instantaneous speed is equal to, which is equal to what? Velocity upon change in time, but our change in time tends to 0. Our change in time tends to 0, and that is called the instantaneous speed. The instantaneous speed is because it is the speed of a body at a particular instant. That's why the change in time becomes 0. Okay, and this expression is also equal to the differentiation of our what is we are discussing. Because it is speed, so it is distance. Okay, here I can write dr upon dt. Here delta r upon dt I can write. R is the, because it is the what? Here again I am saying that it is the instantaneous speed is the limit of our expression, which is delta r upon delta t, as well as our delta t tends to 0. So here it can be also written as dr upon dt, means the differentiation of distance with respect to time. We can, if we will differentiate our distance with respect to time, then it will be called as instantaneous speed. I will give its example. Suppose we have given as a distance, which is here r is equal to some function of time such as 5t square minus t. Suppose we have given as a r is equal to 5t square minus t, some unit, suppose we have meter unit. Okay, and we have to find out the instantaneous speed, that is dr upon dt. Then we will what do? We will differentiate our r with respect to time. So what we got, we have d by dt. We have to differentiate our r, which is the 5t square minus t, and we will got as a 5 into 2, yani 10t minus 1. So we have the answer of 10t minus 1. It is the instantaneous speed. And if we have to find out at a particular time the value of distance, then we can find. Suppose we have to find out our value at a t is equal to 1. Suppose we have to find out our value at a t is equal to 1, then we can easily find out at a t is equal to 1 by putting our 10 into t is equal to 1 in this expression, and we will got 9. So this is an example of the instantaneous speed. Also we will solve the questions in our upcoming videos, and we will give the examples very basic way. Okay, so it was the topics that were covered in our previous videos. So let's begin our next topics, and our next topics will be the upcoming next terms, which is the some terms related to velocity we will define. So let's discuss other points. So now we have to discuss some terms related to velocity. Okay, so first term which here I will mention is our uniform velocity. Just all the terms we had seen in our speed, same terms will be here, which is the uniform velocity. Okay, as well as the terms will be a non-uniform velocity. okay, non-uniform velocity, and then the other term, which is the only the four terms that are included in the previous heading, which is here average velocity, and last term is the instantaneous velocity. But here the things are different because the velocity is different from speed in the sense of direction, and last is the instantaneous velocity. So it is the four topics that we have to see here about the some terms related to velocity. So let's begin. Now over here first topic is, means here first point is, which is the uniform velocity. What is uniform velocity? Just you had seen that what was the uniform speed? Uniform speed was given by the definition that if a body travels equal distances in equal interval of time, that was known as the what? That was known as the uniform speed. And here, because it is uniform velocity, then we have to say that if a body changes its position, okay, we have to include what? Changes its position, because we know that there is no any difference between the speed and velocity. The difference is only one thing, that velocity depends on the displacement and speed depends on distance, and distance is the shortest, not shortest, but distance is the actual path and displacement is the shortest path. So that is the basic differences between the speed and velocity. So uniform velocity can be said as the change in the position, and the position is changing equally. So what we can say to uniform velocity? So uniform velocity is defined that if a body travels, okay, in such a manner that its magnitude of velocity, or we can say magnitude of velocity, okay, and what magnitude of velocity and its direction. So here, and its direction remains same, it is known as uniform velocity because its magnitude and direction remains constant, and this thing is known as what? Uniform velocity. That if a body is having the magnitude and the direction of velocity same throughout its motion, so it is known as the uniform velocity. And the things is said that it is only possible in a motion in a straight line. Motion, we can say in a straight line motion, because we know that if a body is traveling in a straight line motion, then its speed will be same as that of, magnitude of speed will be same as that of velocity magnitude, because speed is already a magnitude. So here we can in this way relate uniform velocity. I will give here example. Suppose a body is traveling, okay, from B to B dash position, and here our body is here a car. So this car will be travel in this direction, and suppose in such a manner it is traveling that after every interval of time its direction is in this direction, which is the east direction. Its direction is always in the east direction. So we will say that this body is what? This body will be traveling in a velocity which is the uniform velocity, and here we can also see the magnitude of this velocity at every instant of time, or we can say after every equal interval of time will be same. So that is known as uniform velocity. So it is clear. What is non-uniform velocity? We have to discuss what is non-uniform velocity. So here we can also define in the same manner uniform velocity. So what is non-uniform velocity? Non-uniform velocity is said for that particle, okay, having non-uniform velocity. So if both magnitude and direction, here both magnitude and direction change, we can say if the magnitude and direction of a body of a velocity changes, or only velocity magnitude or only its direction is changing. Suppose the magnitude of velocity is changing, okay, the direction of velocity is changing, okay, or both magnitude plus direction are changing, then what we say? We say that this kind of body is having the motion of a non-uniform velocity, having the velocity of non-uniform. Okay, so this is known as the non-uniform velocity. The things is same, only example will be different. This body is if traveling in this direction, then what happened? This straight line motion will be become different, and its direction remains, means change. It will change its direction, and if it will change its direction, then easily we can say that it is non-uniform velocity. Now here third, we already had known that the last two definition terms are related to the numerical portion. So here these are only having the formula, so I will write it here. So what is the average velocity? Same manner as I had described previous, that the average speed is the total distance upon total time. So here average velocity is what? We can represent it by this v vector quantity, average velocity barabar, okay, average velocity equal to what? Total displacement, or we can write like this, total displacement delta r vector upon total time. Okay, total displacement upon total time of a body is known as the average velocity. So it is a simple definition of a average velocity, that total displacement upon total time. And here you can only, this is the formula, understand, you can understand it easily. Suppose a body having the different velocity at a different point of time, then easily if you have to find its all the velocity, then with the help of formula of average you can write it. You can know that v1 plus v2 plus v3 upon number of total velocity, that is 3. This is also average velocity formula. Okay, because velocity is a vector quantity, you have to denote it by the vector symbols, arrowhead. And this is the one method, and this is the other method, which is the total displacement upon total time. Suppose you know about the displacement, about each and every displacement you know, then easily you can sum up all the displacement. Means you can find out resultant displacement, and easily you can sum up to the average velocity. Now last thing is here, which is the instantaneous velocity. So what is the instantaneous velocity? Instantaneous velocity is defined as the same as the speed, instantaneous speed, and here it is said to be same, that instantaneous velocity is defined as the, okay, as a such a displacement upon time, or we can say as such total displacement upon total time, for that the time tends delta change in time tends to 0. Means this velocity is given to us in the form of a specific point of time, that is at a particular instant we got this velocity, and that's why we change the time to 0. That's why we write in the form of limit, and this limit we already know that this limit becomes the differentiation of r vector, displacement vector with time. So finally we got the formula. What we got the formula? That instantaneous speed or instantaneous velocity, it is also represented by v, okay, v vector, which is equal to here, which is equal to dr vector upon dt. It is also a formula. So we can in this manner understand all these points related to velocity. Okay, so these are all the examples, and also the same examples as we had taken in our average instantaneous speed. So here we can also take, suppose we have a displacement vector like this, 5t square, okay, or in the form of vector we have to take to 5i cap minus 3j cap, and we have displacement vector in the term of position vector. So here if we have to find out velocity or instantaneous velocity, so what we do, we will differentiate this r vector with respect to time. Okay, so that's why we should have here t as a function of in this function we should have as a t as a variable, and so I will write here 5t square I cap and minus 3t j cap. So we can easily write its answer as a 10t I cap. Okay, it is a method. I will describe all these things in the upcoming videos in all the question solving, and minus 3 j cap. So this is your answer of instantaneous velocity. Okay, so in this manner you have to understand what is the some terms related to velocity. So now let's go through our next heading.